This is going to be a relatively quick video, hopefully, about the One More Orbit flight, circumpolar flight that happened last week starting on July 9th, and some confusion, misconceptions about the flight tracking of that flight. So we're going to go to FlightAware's website and look up that flight, which went by the call sign QE11. And we're going to take a look at the leg from Mauritius to Punta Arenas, Chile. And on that map, we can see that it starts here in Mauritius with a nice green line that ends here and then turns into a white line and becomes a green line again just south of Chile. So there's a reason there's a different color between the beginning of the leg, the end of the leg, and the middle of the leg. And the reason for that is the green section is showing actual position reports. The white section is showing estimated position reports. So from this point all the way to this point, what it's showing you is it doesn't know from ground-based ADS or ground-based radar where this airplane was. It doesn't mean that the airplane wasn't being tracked anymore. It just means that whatever tracking data is available between these 2 points was not coming from ground-based systems that FlightAware will show to the average user of their free services. And the same thing goes for Flight Radar 24. Both these sites primarily rely on ground-based ADS-B receivers, which there are none out here that feed the data to the website. If we go to the track log for this flight, we'll see that FlightAware ADS-B is the source of all the position reports. And we'll also see that in the middle of the flight here, there's a gap in available data, meaning there was no ground-based ADS-B available between 8:30:25 seconds in the morning and 8:52:16 p.m. That's a period of over 12 hours where they weren't receiving any ground-based position reports, which is why this line is not green between this point and this point. When this happens, what they end up doing is they will draw the shortest distance from the end of the last available position report to the beginning of the next available position report. This doesn't mean that this is where the airplane actually was. This is simply the shortest distance that covers the gap in the data. Now, Florence Gomer noticed that in their ADS-B coverage map on FlightAware, they do have a map that shows an entire week's worth of data. And that data includes not only the ground-based ADS-B data, but also their multilateration, their radar data, their data coming from oceanic control areas, as well as their Aireon space-based ADS-B data. So there's multiple methods by which airplanes are tracked. Ground-based radar is one of them. Ground-based ADS-B is another. Space-based ADS-B, which is the Aireon, is another. There is ADS-C, which can go out over VHF data link or over satellite data link. And there's also automated position reports that airplanes can make that don't go to air traffic controllers. The ADS-C reports go to air traffic controllers, but airplanes are also capable of making their own automated position reports that don't go to air traffic controllers. Those go out for the purpose of the owner or the operator of the airplane tracking that airplane. So if we look at just what coverage FlightAware has from ground-based radar, you'll see that although there is ground-based radar in a much larger area of the world than what's shown here, they're only receiving the information primarily from North America, Australia, and New Zealand. So other countries that have air traffic control ground-based radar are not supplying that information to FlightAware. And you can see down here that this map is depicting a full week of flight positions. So all this shaded area here are actually individual flights crisscrossing the country over the period of a week. If we take away the radar coverage and look at just the ADS-B coverage, this is ADS-B ground-based coverage. This is data that they are getting from receivers that are based on the ground, and a lot of this is crowdsourced. You can go out and build your own ADS-B receiver or buy your own ADS-B receiver and sign up to supply the data that you are receiving on your receiver to FlightAware over Flight Radar 24, and they'll incorporate your data into their stream. So from the ground-based data, you can see that there is nothing covering the oceans because they are beyond the range of those ground-based receivers. If we zoom in here to Mauritius, we can see that there is a track going directly southbound, and that is the same track that we saw on the tracking page for QE11 for the Mauritius to Punta Arenas leg. If we go over here to Punta Arenas, we can see the track coming directly from the south into Punta Arenas. Again, this matches the track that was on the map that was specifically for this flight QE11. So beyond this point, the ground receivers were not able to receive the airplane signal. But again, it doesn't mean it was not being tracked. It was being tracked. It was being tracked by Aireon space-based ADS-B receiver. And if we turn on the Aireon, we'll see that it overlaps nicely with the track from the ground-based receivers. And if we zoom out just a little bit, we can see that that track for QE11 extended all the way down into Antarctica. If we go back over to Mauritius, we'll see the same thing. Without the space-based ADS-B, the aircraft's track ends when it leaves the coverage area of the ground-based receiver, but it's still being tracked by the space-based ADS-B, and that track proceeds south all the way into Antarctica. We can even use the altitude range function here. I'm going to turn off the ground-based ADS-B and just use the space-based ADS-B now. We can adjust the altitude range that we're looking at. So right now it's looking at all airplanes from the ground all the way to 60,000 feet. If we adjust the altitude, we can actually watch the airplane as it climbs from Mauritius on its departure. Here it is here, between 10,000 and 20,000 feet, between 20 and 30, between 30 and 40, and then its final cruising altitude was between 40 and 50. And that took it all the way down into Antarctica. Now, if we go over to the Punta Arenas track, we will notice that it ends here. It doesn't go all the way down to the South Pole, and there's a very good reason for that. It's because the temperatures at altitude, at their original cruise altitude, near the pole and just past the pole, got down into something like minus 83 degrees Celsius. So they were running into a situation where the temperature was getting too cold for the operating limitations of the airplane, and they were forced to descend to get to warmer air. So if we take our altitude slider and go back from 40 to 50,000, go down to between 30 and 40,000, we will see here that the airplane was still being tracked. It was just at a lower altitude because they needed to be at that low altitude to find warmer air. Once they got far enough away from the pole and the temperature started to warm up again here, they were able to climb back to their higher, more efficient cruising altitude. We'll see that the track ends just off the coast because this is where their descent was taking place, and they ended up getting below 40,000 feet. And you can see them descend here into Punta Arenas on the satellite-based tracking. So the same thing applies for flights between the southern continents, airline flights, the Qantas flights, for example, from Sydney to Santiago, from Sydney to Johannesburg. You'll find that if you're looking at the free version of Flight Radar 24 or FlightAware, those flights will often disappear from the tracking website once they get a certain distance away from shore, and then it will start showing you an estimated position. And it's not because the flight has been lost, it's because the methods of tracking that flight now are no longer available at no charge. And we can quickly go here. Whereas Wally actually has a very good video out that shows the difference between the actual position of an airplane, a Qantas 63 flight from Sydney to Johannesburg earlier this year, where he has the onboard, he has a position log from an onboard GPS, a Bad Elf GPS Pro receiver that recorded the entire flight. And then he has superimposed that with the data that came from a flight tracking website that only had ground-based ADS-B, and you can see the difference between their estimated position, where they had no ground-based information, and the actual position of the airplane. I'll put a link for that in the description. But we can also look very quickly at ADS-B, frequently asked questions. I'm not gonna read these, but for people who might be interested in what this all is, we can look at what is ADS-B. And again, I'm not going to read it. If you want to read it, you can pause the video there. Why isn't there coverage in my area? This sort of explains why flights tend to disappear when they get over the oceans, and how large is the coverage area. That explains why you see it at a certain distance away from shore generally. There's also some information here on Aireon space-based ADS-B. And they have 100% global tracking. But again, this is information that's not available to the general public for free. But the data is out there. And there are some questions here that may explain a little bit more about how that works. When will it be available? It's already available. It went fully operational earlier this year. Will it be available for free? This is what a lot of people are not understanding. The data is there, but you can't see it for free on the free versions of these platforms. And another common question is, do aircraft need special equipment to be tracked by this Aireon space-based ADS-B? Yes, they do, but no different equipment than is being used to get them tracked by ground-based ADS-B. So the airplane itself has to have an ADS-B transponder, but if it already has an ADS-B transponder in the 1090 megahertz, that transponder will work for satellite-based network. Thank you for watching.